And now it's my pleasure to introduce Valerie Hudson and Veronica Meeks. Valerie is a T-Cubed Systemic PD Regional Supervisor and Independent Consultant, and Veronica is a T-Cubed Regional Instructor and Adjunct Instructor at Tarrant County College. And with that, I'll turn it over to Valerie and Veronica.
Good morning, everybody.
Good morning.
Glad everyone got up early on a Saturday morning to do math.
Yes.
All right. So we have a lot of things to share with you today, and we want to make sure that we have an opportunity to share it all. So let's get started. All right. So this is our agenda for our session. So what issues are we addressing? And we're going to be looking particularly at linear regressions, multiplicity of roots, and forms of quadratic functions. And you can say, well, how did you come up with those? You'll find out as we go along. I'd like to also say that I am semi-retired. I taught high school math for many years. And in my retirement, I'm now teaching at community college. Just a reminder, if you'd like to follow along with us, the PowerPoint, the document files, and the TNS files are in the folder for this session. Can go along with us, or you can just watch, depending on your choice. All right, so learning is a social activity. And because of the big interruption we had with COVID, many students are missing the foundational skills that are integral to making connections between different concepts. And as a teacher, I can perfectly speak. We all struggled with what to do to help students without having to teach those concepts or connections they missed during the COVID shutdown. Because in my particular case, I left at spring break, didn't know we were going online virtual until at the end of spring break, when spring break ended up being 2 weeks. And then we just punted for there. So what are we seeing as the after effects of the situation? Well, we're seeing after effects at all grade levels. To share with you a little bit of why this is happening, there's an article recently published by the AP News that describes student struggles. So there was this young man at a university. He was taking a math placement test for his first year of college, and he was someone who had aced physics and computer science in high school. And this is how, but he couldn't pass the math placement test. He says, I didn't have hands-on in-person class, and the information wasn't really there. And then he felt like he struggled when it came to the higher level algebra because I just didn't know anything, because that's what he had done virtually. So he hadn't really taken into himself the things that he'd done virtually. And one thing that we did try to do for the presentation is, if you're really, when you get the PowerPoint, is we did put a link to the actual article that we pulled the information from so that you could read it in entirety. Okay, so there are some issues that we had. Even before the pandemic, the US was trailing other countries in math literacy. The 2019 PISA exam, which is an exam that is given internationally, from different countries, found the US scored 31st out of 79 countries. And so this was from a USA Today article in 2020. As for any current data, they just shared the NAEP data, which is the National Assessment of Educational Progress for 2023. And there was a drop in the mathematics average score compared to the previous exam that they had done in 2019 and 2020. So there was a substantial drop. And I don't know if you went to our main speaker, Dr. Gray. He was talking about indigenous populations. And so when you look at this data with the nation's report card link on the bottom, what you'll see is one of the groups that was most hard hit by all of this was the Native American population. All right, so Now that this has happened, what can we do? We can't go back and repeat a year. We can't go back in time. So we're looking for different organizations to kind of, or different researchers to kind of give us some hint as to what we can do as instructors to help do this. So there was a NCTM and NCSM have published a research and advocacy article to help focus some of the discussions and conversations going forward. So here are the suggested strategies they have for teachers. So we want to set math goals that focus on learning. We want to implement tasks that promote reasoning and problem solving. We want to use and link mathematical representations. We want to facilitate meaningful problem solving. And we want to ask questions with a purpose. So we want to be very intent that planning is extremely important in trying to get ourselves back on track. All right. When a coherent and connected approach is taken from content from previous grades the students may have seen to be missing, they can be taught along with grade level content or just-in-time support. So this was a quote that I think directly dealt with how we're suggesting we deal with the situation. It's the choice of tasks and activities that we do become extremely important. And we want to choose tasks that are rich enough, that incorporate enough of previous content so that we can find those places that students may have some misunderstanding or just be simply missing content. So one of the things in some of the articles we read for this, to get prepared for this session, is geometry was one of the contents that was often skipped because a lot of people felt that the algebra was a lot more important to follow along with than some of the geometry. All right, so what we did was to kind of help along with what we do to decide what we wanted to do. We know that testing is a very important issue that we have to deal with, especially if you teach Algebra 1, if you teach middle school math, or in some states even above Algebra 1. So what we did is we did kind of looked at a few of the state exams to kind of look at questions where we thought that probably that we need to look at making sure that we have the connections we want. And so we looked at the New York Regents exam, Algebra 1. This was the one that was released for June of 2023. And we looked at the Maryland exam, and we saw that there was these some in the case for the New York Regents, an open-ended exam on linear regression and correlation coefficients. And then also that there was also in the Maryland exam, the same type of thing with dealing with correlation coefficient. And of course, since I'm in Fort Worth, Texas, we had to look at the Texas STAR. So the STAR actually had quite a few questions that were on correlation and linear regression. They even had a question where the students were anticipated in being able to do quadratic regression. So that kind of guided us to pick this first topic as one that we would focus on. So here we go. You can take it now, Ms. Valerie.
All right, thank you very much. So hopefully you can see my screen. I'm Valerie Hudson, and I'm also here in the Dallas-Fort Worth area with the fabulous Veronica. And so we're going to talk about the activity investigating correlation. And if you didn't see in the chat, the materials will be available after in an email after the conference. But obviously, you can get to investigating correlation right now. It is an activity that is on the TI website. So with all of the TI activities, there are teacher notes, student notes, as well as, or student activity, I should say, in PDF as well as Word form. And so the teacher notes are very, very detailed, starts out with objectives, goes into vocabulary, what to watch out for, various tips. If you have Navigator in your classroom, then it'll give some tips on that, as well as the answers. So that's nice. But we're going to concentrate on the student activity. So with that student activity, We're going to start out with a scatter plot, as it says here in the instructions. We are going to talk about relationships as well as the correlation coefficient that goes along with that. So let me pull that up and I'll make it a little bit bigger. There we go. So as it says, we're going to move to page 1.2. And here are two scatter plots. Obviously, we are given a correlation coefficient on both. Students have to talk about, and this is all assuming students don't know anything about correlation coefficient. And so students are asked to make some predictions based on the data on both sides. So obviously here it would be easier for them to make a prediction. Obviously here, not so easy. And then what do you think the correlation coefficient has to do with the ease of being able to make a prediction based on our data? Now, these activities on investigating correlation also allow students to move the various data points. If we don't unclick, then we'll be moving two at the same time. So unless you want to move two at the same time, students need to remember, click off of the circle before moving. And so then they are able to change the correlation coefficient as they change their data in order to make additional predictions if they want to. So on the next section of the activity, students are dealing with pairs of scatter plots, and they have to decide which scatter plot shows the stronger correlation. So the correlation coefficient is not given here. They have to make a determination themselves as far as which one is stronger. And if we press the little slider button here, then we have different choices. All the solutions are on the next page. And so again, the students are able to see, well, what was going on with graph D that gave us a larger correlation coefficient than we had on graph C, and various other comparisons. The next page allows students to match a target. So this goes back to the idea that I previously said as far as moving a point or points on the graph to change the correlation coefficient. So they have their target here. This is their current correlation. So they have to move their data points in order to get as close to the target as they possibly can. And so in this activity, the students are learning for themselves that the more linear we are, the closer we're going to get to a larger correlation. And of course, the target can change too, especially like the negative one, because students don't necessarily think about that one. So on the next page, students investigate the two plots and select the points and observe what happens. So if I choose this one and then move it, then we're dealing with inverse graphs, and there's a lot of good conversation that can happen with this as well. On page 5.1, or the last section of our activity, students drag points to modify the scatter plot, and then they can also reset. And so again, this would be an activity where students want to get as high of a correlation that they possibly can. And this is where they hopefully determine that the largest value for R that they can get is 1. And of course, they can also move the points around and get that R value of -1. right, let me reduce that. So circle up is the next activity, and Veronica is going to take that one.
All right. Share my screen here. Okay, so of course, I don't know about you, but I'm always a busybody. I always have to kind of look at things. I like activities that are already created, but I also like to make my own. So this is one of the activities that builds upon what this previous activity for linear regression is, and actually have them look at linear regression in terms of a situation. So one of the things that we talked about earlier is that we felt like geometry was a lot of geometry content was left out during the COVID shutdown. To me, measurement, if there's something that always is kind of given, is actually people actually physically measuring objects. So the idea of Circle Up is for students to actually take actual data and put it in and be able to look at the relationship between radius, diameter, and circumference. So the way that this is set up is you would have students in groups, and you would have each group have maybe one or two objects that they have to measure the radius, the diameter, and the circumference. So you would need a measuring tape to be able to do that. So since this is original activity, it doesn't have teacher notes. We are going to, or I'm going to create them a little bit later on. So if you email one of us, we'll be happy to share that with you. So what we are going, so I'm just showing you what the student page looks like, and then I'm going to spend the rest of the time on the TNS file. So they would collect the data. And if you don't have a navigator system, what you can do is that you can put a poster up or use a whiteboard in your room, and you can have the students put up their data as they collect it. And so we're going to go to the TNS file now. And so we have it Circle Up, and this is also in the download that you'll receive. On the next page, we're going to have we're going to take the data you gathered and input the information on the next page. Now, what I did put in here, if you do have a navigator system, you can actually have, instead of students copying it from the poster or the whiteboard, you could actually have groups send out this poll question and have them input their data so that you can create a group data list and then send it back out. So that way you don't have the students have the data that they have, and they don't have to put in all of it. But that's only if you have a navigator system. If you don't, you could have them just put the information in. So what I did was I made up some data, but I want to have more data. So in the directions for the activities, we're going to fill up that table that they had on the original student page by actually gathering data on their calculators. So we have a page here where a circle is already created, and the measurements are already done for the radius, the diameter, the circumference. So what we want students at this point is to take their table and then just drag it. You grab a point on the circle and just drag it until they like the measurements, and then write them down and add them to your table. So what you want is that you want the students to have more data points. You don't know how good their measure is. So you want to have kind of a good data that has a little bit more consistency with it. And so if we go back, I actually went back to the spreadsheet we had on 1.4, and I made up some data, and then I entered data that I collected by grabbing the circle. So once they've done that, in the directions for the activity, it has you graph radius versus circumference. So we're going to click here, and we're going to put the radius, and we're going to click here, and we're going to put the circumference. And then we're going to look, and the question that they ask in the activity is, this is considered to be a linear relationship, why? So this kind of gives you an idea of where the student's understanding and their definition of what a linear relationship is. Afterwards, what we're going to do is we're going to go to menu, and all of these directions are in the student pages. So you don't have to worry about doing this. And we're going to go to analyze. And what we're going to do is we're going to add a movable line. And you can say, well, why are we doing that rather going straight to regression? We're trying to make connections with something that they did in middle school, which is a trend line. So a movable line is a way for you to approximate. So you can move this line and have it, the students adjust it to whatever they feel is a line that they feel that fits the data. So once they've done that, they write down that equation, and then we're actually going to do the regression line. So we're going to go to menu, and we're going to do analyze, and we're going to go regression, and we're going to go linear regression. And so here you can see the linear regression equation. So we have the students write that down also, and then do a comparison of the two equations and see what they have in common and what they don't have in common, so that they can see that. Now, at this point, now that we've done that, and they can talk about the difference between a trend line. For example, if you have somebody's measurement was way off, you could have an outlier. So the regression line could be a little bit off, and you could have a conversation there about their data. Let's say I want to find the correlation coefficient. So I wanted to make sure that I showed people how to do this. We're going to insert a page by hit Control Doc. And we want to do a calculator page. And we're going to go menu, and we're going to go statistics. And we want to choose our linear regression statistics. So our list was in radius and circumference. And we click OK. And so there we have our statistics that we want. And we also have our correlation coefficient. So you can see that for the data, wasn't good about messing up my original data here that I measured, that is 0.996. And so from the previous activity that Valerie described earlier, you could have a conversation with students about what is the value of that and what does that mean about how close to linear this is. And so I went ahead and did the diameter and circumference. And so when you go in the student pages for diameter circumference, we don't have them doing a trend line. We're just having them do a regression. And then we're going to take the time, and I'm going to pull back up the activity so you can see what I'm talking about here. We put all the different directions in there and the conversation questions that you have. But what we want to look at is, what is the relationship with the radius and the diameter? And how did that affect the equations we got when we did the regression equation for each one of them? And then have them actually use those equations to find the circumference and given a radius and given the diameter, and then go back to, okay, these are geometric formulas that we already know. How do those regression equations that we came up with connect with the equations the formulas that we're given to find circumference given a radius and circumference given a diameter? The last part of the activity is one that you could actually do where we also look at area. So you can use this as an extension activity where you could go into area and you can do the same thing we did, and the circle is right here. What you want to do is that if you can collect the data here, and then there's a new spreadsheet set up, but it's set up like a data capture. So if you hit control period, it adds that piece of data to your spreadsheet. And then you can have the students capture 10 or 12 different circles because you change the circles just like we did on the other by grabbing the circle. And then you can do a analysis. Oh, is radius to area, is that linear? So this is an extension activity that kind of gets you into the idea of what you're doing. All right. So that is Circle Up. So hopefully that gave you some ideas. So I'm going to turn it back over to Miss Valerie.
Awesome, thank you. So there were some good questions in the chat. One person asked if there's any free materials. As far as software, there's TI-Nspire Connect, which I put that information in the chat, and that will allow you to download activities, the TNS documents for TI-Nspire calculators. So that is web-based. It'll allow you to download activities from the TI website, or like the activity that Veronica created. Once you get that folder, you'll be able to use, or you can use TI Connect to get that. And someone asked, can we do this activity on the TI-84 CE? Well, we can make various circles and change the sizes using Cabri Jr. As far as that particular activity itself, we did not. This is set up for Nspire, so we didn't make it for the 84. But if you know Cabri Jr., then you can definitely grab and move circles and see those various changes.
We were kind of under a time constraint, so we didn't.
Yeah.
We thought about doing 84 activity, and we may actually do it a little bit later on.
But we're already halfway done, so, and we still have a lot to talk about. But one thing you can do on the TI website, education.ti.com, no www in front, but sorry. But one thing you can do is search in activities and just type in a topic, and you can find various activities already made. And not sure about the 84 because we didn't really search for that, but you can definitely do that search yourself. Again, that's education.ti.com. All right, so moving on. Then if you are new to Nspire and you don't know how to find, or your students don't know how to find the correlation coefficient yourself, two resources. This one here on the right, the written resource that just walks you through how to find the correlation coefficient. And then the video I made, if you'd rather look at a video, talks about the correlation coefficient as well, and making predictions or taking that stored information and then using it. We'll put the email in the chat in just a little bit. Thank you. All right, so from the New York Regent exam, these are a couple of questions that were, let me make this a little bit bigger here, that gave students some issues. And so obviously we're dealing with various polynomial graphs, and students had to find the zeros, had to write the equations. So based on that need, multiplicity of zeros, we think, is a very nice teaching tool for students. So let me get, oops, too much. Let me get out of that so I can pull up multiplicity of zeros. I'm sorry that, give me a second. There we go. Okay, so with multiplicity of zeros, again, the teacher notes, very, very detailed. I'm going to go over here to the student activity here. And so we'll be dealing with sliders, and students will identify the x-intercepts, zeros, talk about the degree of the polynomial, talk about the end behavior, have to write equations themselves based on graphs. So let me pull up my software here. I know sliders are pretty cool, and I'm sorry, something is trying to open, which we do not want. All right, there we go. Okay, so multiplicity of zeros of functions. So here we have a graph. Obviously, the equation is given. Students are asked for the x-intercepts and zeros, so we're tying that vocabulary together. On the slider, we have yet another graph, and we have quite a few different graphs. And students are asked similar questions. For the next section, again, various graphs. Students are asked on this next section about end behavior, which is very nice. They're also asked on both sections what's happening, where the graph might bounce off of the x-axis. Why does that happen? What does the equation look like? So back in the student notes, at the end of this activity, students are asked to, based on given information, they are asked to write their own equations. So I thought this was a very nice activity for Algebra 1, Algebra 2, depending on where you are in the country or in the world, because we have people from other countries here. For this one, or these two, these are two questions that came off of the Texas end of course test STAR for Algebra 1. And these, again, are some questions that gave students some issues. So for those, there's two activities. One will be in the folders called Linear Factors of Quadratics, and I'll show you what it looks like. I didn't make, because I made it, I didn't make written directions for it, but I'm actually going to show you how you can have your kids make it themselves. Or if you'd rather just use the TNS document in the folder, great. There's also an activity called Zeros of Quadratic Functions, and that one is here, and that's from the TI website. Also very, very nice activity. But I think there's some value instead of having an activity that's already made, having the students do it. So what I'm going to show you with the linear factors of quadratics, it's basically very, very similar to what's here. So let me pull up my software again. And I'll show you the activity first, and then, so I have some directions. So this will be in your folder. So I have some directions. We have a couple of lines. Students will be able to grab and move the lines. And then what happens when we multiply those lines or those equations together? We'll turn that F3 on, and then we can have very rich discussions with kids about, all right, so what's the relationship between the graph of the multiplied equations and the zeros or the roots, however you want to describe them, the solutions for the linear equations. So this is how you can make this yourself or have your kids make it. So I'm going to go to a new document on my computer. Of course, kids can do this on the calculator itself. I'm going to a new document. I'm going to a graphs page. Now, obviously, I have the grid on the screen. And if you don't, or your students don't have the grid on the screen, they can just press menu. They can go to settings. That fourth choice there, line grid, is what you want. And then OK. There's another way of doing it, but I think the settings is great because that'll keep your graph on all the time. All right, so the first thing we need to do is type in a linear equation, whatever equation you like. So I'll just write 2x minus 1, sure. And then we'll type another one. Again, it can be whatever you want, maybe x plus 4. So at this point, again, you can have your kids grab and move the lines however they like. Ask them to find the solutions either by hand or where's that x-intercept, however you want to do that. Same thing for the other graph. But then ask them, well, what happens if we multiply those two equations? What do we get? Oh, let's let the calculator help us with that. So since my two equations were typed in f1 of x and f2 of x, I'm just going to multiply f1 of x and f2 of x. So f1, now notice when I typed that 1, it got bold. So that means the calculator knew. That means something because we gave it a meaning when we entered that equation. So f1 of x multiplied by, so we do have to have the multiplier, and then f2 of x, and there's our corresponding quadratic. And again, we can move our lines, that changes the quadratic. We can have those very rich conversations about what's the relationship between the solutions for the linear as well as the quadratic graphs. All right, so again, zeros of a quadratic function from the TI website does the same. So you can either have your students make that activity or use either activity that you like. I think it's nice for students to see that relationship because they don't always get that on their own. All right, Veronica, do you want to take this part?
I'm not gonna share my screen, so I'll let you keep sharing since you're gonna talk about the next activity.
All right.
So what we saw was students, and this kind of differs from when we actually learn mathematics, because when we study quadratics, we talk about the vertex form, we talk about the standard form, but really there's a factored form that's becoming much more and more important as we have more technology. So really there's three forms that we need to look at. When we study linear functions, we spend a lot of times talking about the different forms and comparing them and deciding which form do we use, slope intercept, point slope, standard form, which one gives us more information. We don't often take the time to do the same thing with quadratic functions, to look at what information is given by each different form, what is the value, and how these forms are connected. So we came up with this activity. Valerie is very good about sliders. She's extremely excellent.
Well, thank you.
You're welcome.
So the activity is called Exploring Forms of Quadratic Functions. And Veronica, yes, I made the activity, but Veronica is good about making the document to go with it. I'd rather just talk and, hey, what do you see, kids? And we go from there. But it's also nice to have something concrete. So thank you, Veronica.
You're
So
welcome.
this is let me get rid of that. So this is exploring forms of quadratic functions. And it starts out with standard form for a quadratic. And we'll talk about what do all the parameters mean. And then we'll get into the other forms of the quadratic and then compare. So let me pull that up. That big. All right, so the TNS or calculator document that goes with that is called quadratic sliders. So we have our quadratic. Notice it is in standard form. If I press the A value, then we have questions. What's going on with the parabola? Oh my goodness, it turned into what looks like a line, and so on. And so all of our parameter changes are shown here. On page 2.1, we have the vertex form. And again, questions in the handout or verbally. What's going on with this parameter? What's going on with this one? What's going on with this one? On 3.1, we've got the factored form, same idea. What would be, and for all of these versions of the quadratic equation, students are asked what information is easy to identify. So would the y-intercept be easy to identify here? Would the zeros be easy to identify here? Would the max or min be easy to identify here. And then they have to explain why. And that's for all of them. And then as we continue on, we have comparisons between the various forms. So the students have to identify, well, which parameter or parameters looks like it's doing the same thing. And the same thing here. And here. So again, just helping students to see the relationships between the various options that they have for quadratic equations and what's the benefit of using one equation over another one, depending on what we want.
Valerie, why don't you go back to the document we created to go with this so we
Sure.
can kind of show those pieces.
Okay. Let me make this bigger.
Because we have time.
There we go.
All right. So
Okay.
one of the things that I did when I wrote the page to go with the TNS file is that I want students to be able to you do certain things that they're required to do on tests, which is, okay, if you have a quadratic equation, you have to find the vertex, you have to find the x-intercepts, you have to find the y-intercept, and you have to find the axis of symmetry. So I had them do this for no matter what form was given, so that way they can see, maybe they can analyze and see which form they have to look at, and then they have to make a conclusion about, in this form, what can I easily find? And the same thing happens with the vertex form. What thing is to do, find the same information, make up two equations, and they ask which one tells you something specific about the characteristics of the quadratic function, and then they have to make a statement. And so then we do the same thing with the factored form. And we talk about the same type of things and ask them, what do we easily see from the factored form? So the last part of the page that we came up together was talking about what parameter is common to all the forms and how can we see that? So that's where you get to the last 3 pages that Valerie described. And then I added some problems where they had some descriptions, and based on the descriptions, they had to decide which form is the most effective to use. And they have to make up an equation that matches that description. So that gets you into some common ways that we use quadratic functions that we're asked to manipulate them and come up with the different functions.
And I also love in the application that it's very open-ended. So we're asking for specific information, but the students do have some leeway as far as what type of or which equation they're going to use.
And you can also have the conversation. Some of them have multiple answers, and then some of them have a specific answer. So what about the information, the way it was given, makes it one more open and one more specific? All right.
Thank you.
We have a little time here. If you does anybody have any question? Oh, we hit somebody's timeline here. Somebody's teaching this next week.
That's awesome. Well, I'm sure you'll get the materials before next week. So good.
Hopefully right after the session. Does anybody have any questions for us? Oh, we hit it. We hit a timely thing. Everybody's talking about this is my next unit.
Absolutely. That's great.
Yeah, I had never really thought about comparing the forms until I actually looked at how much time we spend on, especially in Algebra 1, comparing the forms for linear. But we don't do that and go in between each time. And then an extension would be, how do we algebraically manipulate one form to the other? So to me, that lends itself to having a purpose for being able to go between using the idea of completing the square and being able to factor. That gives a purpose to those skills. So to me, that helps out a lot. Oh, Valerie put her information up there. Oh, I need to do the same thing.
Yes, you do.
All right. I actually am retired, supposedly.
Me too, supposedly.
So I'm putting up my contact information up there. And you are welcome to contact us. I do understand for the people that disappointed that didn't have this for the 84, and to make you feel better, I have to use the 84 at the community college. So my intention is to revamp these so that I can use it on an 84. So if you send me an email, give me some time here. If you send an email in a couple of weeks, I might have something for you. Yeah, I say you were talking about we used 84 at the college level. The college is a kind of a mixed bag. Yeah, we like the supposed retirements too. That my family doesn't, but I do. Thank you for being so patient for us.
Yes, thank you.
So I think we have Eric.
Yes, we do. Let me pull him up. Oh, yes, I almost forgot. So if you want to know how to make sliders, since you did see some sliders in here, there's a very nice video that TI-ETC Virtual T created on using sliders to teach transformation of function. So check that out.
Awesome. Well, thank you, Valerie and Veronica, for both sharing your expertise. And is there anything you want to speak to here on the bibliography?
We wanted you to be able to not just take our word for it, but we did a link for every document that we went to, including where we got the sampled question items, so that you could actually look at some of these and read them and further. Some of them have some really nice suggestions.
Awesome. Fantastic. So I see in the question, will the links get emailed? So all of the session resources, including the recording, will be available after the session. You will receive a link to that in a follow-up email sometime next week. So again, thank you, Valerie and Veronica, both for sharing your expertise. And thanks to everyone for attending. We really hope that you enjoyed the session and found the time valuable. Without any further delay, the lucky winner of a TI graphing calculator is Sonia Scott. So congratulations, Sonia. And we will follow up with you early next week. We have your contact information from when you registered. So we'll follow up with you next week, Sonia, about next steps with your prize. And then again, next week, everyone will receive a follow-up email with links to the session recordings, the certificate of attendance, and then all of the associated resources, not just for this session, but for all sessions that we're presenting today. So thanks again for joining us, and I hope you have a wonderful time at the rest of the T3IC virtual conference. Thank you.
Thank you.
Thank you. Bye.